All right, I forgot to start the recording, but that's the answer to the first one. Okay, so on number 2, since the $5 goes with the cheese and the $6 goes with the one topping, then we need to make sure those amounts are paired together in our equation. So I could roll this one out because it doesn't include the C or the D for the toppings. This one doesn't include the prices, so it's down between these two, and you can see that the only difference is that the prices are paired with different things. So was the cheese pizza $5 or $6? It was 5, so it's going to be that one, not that one. All right, this is part 1. An artist is selling children's crafts. Necklaces cost $225. Bracelets cost $150. Write an expression that would represent the situation with N necklaces and B bracelets. So you just need to make sure the price is matched up with its correct variable. So necklaces are $225. So the only one where $225 is paired with necklaces is D. And then double check, $150 is paired with bracelets. So that matches up. Does that make sense?
Yeah.
Okay. Then it wants us to use that same equation, 225N plus 150B. Use the equation above, select all the combinations of necklaces and bracelets that the artist could sell for exactly $12. All right, so they're telling us what N equals, and they're telling us what B equals. So in order to solve it, you could just simply plug these into our equation and see if it makes it true. It has to equal exactly $12. Okay, so let's try A. Necklaces, we're going to order 5, so 225 times 5 plus 150 times 1, and that needs to equal 12. I think I have a calculator right here. All right, so I have 225 times 5. That gives me 1125 plus $1.50 times 1 is still going to be $1.50. So we have 1125 plus $1.50, and that equals 1275. Does 1275 equal 12? No. So is A, would A work? No. All right. And for time purposes, I'm not going to go through all of these, but that is how you would do it. So you're going to select all of the ones that would work in that situation. And for those of you that don't have your study guide finished, I will tell you there are 3 correct answers to that one. All right, next, this is where a lot of people have been messing up. It says solve the following equation for y. Why do we need to know this skill? Why do we need to know how to solve an equation for y?
Because we have to know how to do substitution.
We have to know how to do that to do substitution. Why else do we need to know how to do it?
Because it makes us smart.
Yes. What?
Graph it.
That's what form it has to be in to graph. Okay, so currently this is in standard form. And it wants us to solve the following equation for y. Well, we know if we have an equation that has 2 different variables in it, we can't solve for y or x. You cannot solve an equation that has 2 different variables. All we are doing here is rearranging our equation to get it set equal to y. Okay, a lot of people miss this on the study guide. So we have 3x plus 5y equals 15. We are rearranging it to solve for y. So if we're doing that, we need to start with a term that is furthest away. So how do I get rid of a positive 3x? Minus 3x. If I do it to one side, got to do it to the other side. What happens to my 3x's? They cancel out. So I bring down my 5y. Can I combine these 2 terms? No. And we've said that over and over again, but still people try to write 12x. Okay, you cannot combine these 2, so you're just writing it out. Okay, next. I'm trying to get this y by itself, so I still have to get rid of this times 5. How am I going to do that? Divide it by 5. If I do it to one side, got to do it to the entire other side. What happens to my 5s? They cancel out, and I'm left with y equals, what's 15 divided by 5? 3. And then I have a -3 divided by 5. I can't do that in my head, so I'm going to use my calculator. -3 divided by 5. Do I want to keep it as a decimal? No, so I'm going to go to math, enter, enter, and I get -3/5 x. So that is how I would put my answer. All right, next one. Solve your equation for y. Once again, we are just rearranging it. Okay, so I have x minus 6y equals 24. We're solving it for y, so we start with the term that is furthest away. How do I get rid of my 1x? Minus 1x. If I do it to one side, got to do it to the other side. All right, what happens to my x's? They cancel out. What do I have left?
6y equals
6y?
negative 6y.
-6y. That's where a lot of people are going to miss it on the test. You have to pay attention to that symbol in front of it as well. So -6y equals, can I combine these two? Nope, I have 24 minus 1x. You can write the 1 there if it helps you to see that. Okay, still trying to get that y by itself. What do I still have to do?
You have to divide
-6. If I do it to one side, I got to do it to the entire other side. What happens to my -6's? They cancel each other out. Y equals, what's 24 divided by -6? -4. If you didn't know that, 24 divided by -6, -4. Next, I have a -1 divided by a -6. -1 divided by -6. Do I keep it as a weird decimal? No, math, enter, enter. What do I get? A positive 1/6. So plus 1/6 x. Because a lot of people are going to forget to bring that negative down. If you miss this one, you probably got +4 minus 1/6. And the reason that's the answer you got is because you forgot to divide it by a -6. So there is your answer. Okay, next. We have an equation. It wants to know what the slope is. Well, in order to know what the slope and y-intercept is, what form does my equation have to be in? Y equals mx plus b, or slope intercept form. Is that what form it's in?
Yes,
How do I know?
because it says y.
Because it's already solved for y. So let's look. What's my slope? 3/4. How do I know that?
Because it's the number.
It's the number paired with the x. So my slope would be 3/4. Okay, what is my y-intercept?
-1.
-1. It's the number all by itself. Next, we have an equation. It wants to know once again what the slope and the y-intercept is. So since slope is the number paired with the x, is it 8?
No,
No. What do y'all notice about this equation?
it's not so equal.
It's in standard form. So if I want to know what the slope and y-intercept is, what do I have to do to this equation first? I have to solve for y. Okay, so I'm going to come over here. I have 8x minus 4y equals 24. If I'm solving for y, I start with the term that is. How do I get rid of a positive 8x? minus 8x. I do it to one side. Gotta do it to the other side. What happens to my 8x?
Cancel.
They cancel out. I bring down my what?
-4y.
Negative 4y. Good. Can I combine these two terms?
No.
Nope. All right, I'm almost finished. How do I get rid of this? Or how do I get this y by itself? Divided by -4. Okay, what happens to my -4s? They cancel out. Y equals, what's 24 divided by -4? Nope. 24 divided by -4 is -6. All right, -8 divided by -4 would be +2. All right, so now we have it in slope-intercept form. So now it wants to know, what is the slope? If I'm looking at my equation set equal to y, which number is the slope?
2
2. It's the number paired with my
x
x. What is my y-intercept?
-6.
-6. Next, it says graph the following equation. Now, when you're graphing, you have all these like tools over here. One says like point, something else, something else, something else. You're going to click on the one that says line. Okay. All right. It wants us just to graph the equation. So this is a skill you actually did last year. So in order to graph, we need a slope and we need a y-intercept. Can we find that by looking at this?
No, because it's in standard.
Nope, because it's in standard form. Good. So what do I have to do to this equation first? I have to solve for y. So let's do that. So I have 6x plus 3y equals 12. Solving for y. So I start with my term that is, how do I get rid of a 6x? Minus 6x. If I do it to one side, gotta do it to the other side. What happens to my 6x? Bring down my positive 3y. Can I combine these? Nope. So I have 12 minus 6x. All right. How do I get that y by itself? Divide by 3. Those 3's cancel. What's 12 divided by 3? 4. What's -6 divided by 3? What's 6 divided by 3? 2. A negative divided by a positive is a negative. So -2. Bring down my x. All right, so now we have to graph it. Where is this line going to cross through my y-axis? +4. Okay, remember we've clicked on that line button first. I'm going to click on -4. All right, and then what's my slope? -2. Since it's a whole number, it's understood to be over 1. So I'm going to start at my 4y. I'm going to go down 2 and to the right 1. All right, and once you click on that spot, it's going to draw a line and then you can submit it. Whoops, hit my nail. All right, so there's your line. It's not an inequality, so we're not shading above or below it. Next, it says graph. Yes.
That didn't work for me.
When you clicked on line?
Yeah.
Well, I don't know. Hit reset and try it again. That's the way you do it.
Okay.
Next, it says graph the following systems of equations. I know it's a system of equation because I have multiple equations and it's connected by these brackets. So, am I ready to graph them?
Yes. Yeah.
Yes, they're in slope intercept form. They're solved for y. So if I look at this first one, where is it going to cross through my y-axis? +3. So once again, I'm going to go over to that little toolbar. I'm going to click on where it says line. And then I'm going to click that +3 and it should graph a little dot. Okay. What is my slope? 2/1. So I'm going to start here and I'm going to go up or down? Up to the
Right.
right 1. And then it should create a line for me. Yeah.
What I had trouble with this one was I couldn't go between -1 and -2.
You couldn't what?
See right there where it crosses through -1 and -2.
Mhm.
It doesn't have to do that. It has to get the whole thing.
Yeah, that's why if you just click on that line button, then if you just click those 2 coordinates, then it should create the line for you. So why? So that. So if you go there, you go up to the right one. No. If you want to, the right one, and then one. All right. That's a little off too, because I didn't go straight through my point, but it's okay. Next, it's solved for y, so we can look over here and we know it's going to cross through my y-axis where? -4. So I'm going to graph that point. Make sure you click line first. All right, what's my slope? -1/3. That means I'm going to start at my y-intercept and I'm going to go up or down? Down. How many?
-4. Oh, wait, down
Down 1
over 3.
over 3. Down 1 to the right, 1, 2, 3.
I didn't see, your pen was on the dot. I have to look.
Ah, gosh, I'm butchering that. All right, and because I was off a little bit, mine's not perfect, but it intersects at -3, -3. Mine's not perfect, so it says, what is the solution? -3, -3. If you do it on the thing, it you can see where it intersects. Luke, did it work that time?
Yes.
Awesome. All right, a few more and then we are finished. Once again, it says graph the following system of equations. So this first one, am I good to graph it?
Yes.
Yes. Why?
Because it is equal to y.
It's set equal to y. Am I good to graph the second one? No. Why?
Because it's not. It's in standard.
It's in standard form. So I'm going to use pink for this, but before I can graph it, I need to come over here and I need to solve it for y. I need to get it in slope intercept form. Okay, so I solved for y, so I'm going to start with the term that is furthest away. How do I get rid of this positive 10x? Minus 10x. If I do it to one side, got to do it to the other side. What happens to my 10x's? All right, what do I do with this positive 2y? Bring it down.
I don't know why I'm doing that.
All right, so can I combine these two terms? No. So I have 20 minus 10x. Am I done? No, got to get that y all the way by itself. So how do I get rid of that 2?
Divide.
Divide by 2 on both sides. My 2's are going to cancel out, and I have y equals, what's 20 divided by 2? 10. What's negative 10 divided by positive 2?
Is it negative 5?
It's negative 5. Bring down my x. All right, so I'm now ready to graph that, and I will graph it in this pink color. So let's do it. Let's go to the first one. It's set equal to y, so where's it going to cross through the y-axis? Positive 10. All right, and what is my slope? Negative 2 over positive 1, because it's a whole number, it's understood to be over 1. So I'm going to start at my y-intercept, and I'm going to go up or down? Down how many?
2,
2, and to the
right,
right 1. All right, there's my line. You don't have to graph all those points on there. If you just click that line button, it'll create the line for you. All right, now we're going to graph this pink line over here. Where's it going to cross through my y-axis? Positive 10 again. All right, what's my slope? Negative 5 over 1. Okay, it's a whole number. It's understood to be over 1. So I'm going to go down 5, 1, 2, 3, 4, 5, and to the right 1. Down 5, 1, 2, 3, 4, 5, to the right 1. Nails are too long. All right, so do these two lines intersect?
yes, at the top.
Yeah, they do right up there at the top. So it says, what is the solution? We know the solution to a system is that point where they intersect. So what is the coordinate where they intersect?
0, 2.
0, 10. All right. Almost finished. So this says y equals 6x minus 11 and negative 2x minus 3y equals negative 7. It wants us to solve it by substitution. So the main thing you need to look for when you're solving by substitution is to check, is one of my equations already solved for a variable? Is it? Yes. So it is perfectly set up for us to solve it by substitution. So what we're used to is we're used to seeing an equation that looks like this. Right? We're used to having an equation and knowing that y equals 6. So what would we do with that 6? We would substitute that in for y, okay? Well, substitution this new way is the exact same concept, but instead we're going to take everything that y equals and substitute that in for y. All right, so we're rewriting the equation that we're substituting into. All right, so did anything change with my negative 2x? No, so that stays the same. Minus 3, that stays the same, but instead of y, we're going to substitute in 6x minus 11, and that all equals negative 7. Okay? So right here, we're going to take our first step. Once we have substituted it in, that's the only new thing you learned this year. Everything else is just simplifying. So we take that negative 3, and we're going to distribute it throughout our problem. Did anything change with my negative 2? Nope, bring it down so I don't forget it. What's negative 3 times a positive 6x? Negative 18x. Negative 3 times a negative 11?
33.
Positive 33. Okay, because a negative times a negative. All right, so now we have these like terms. So after we distribute, our next step is to combine like terms. So I have a negative 2 minus 18. It's going to give me a negative 20 plus 33 equals negative 7. So now, because I've simplified it, I have an equation. I'm ready to solve for x. Okay, I have an equation in one variable, so I can actually find what the solution of it is. So if I'm solving for x, I start with my term that is furthest away. So how do I get rid of this 33?
Oh, minus 33.
Minus 33, if I do it to one side, got to do it to the other side. Those cancel out. I have negative 20x equals negative 7 minus 33 is going to give me a negative 40. I'm almost finished. How do I get that x by itself?
Divide.
By
20, negative 20.
divided by negative 20, not the x. All right, those cancel out and x equals 2. All right, but we know the answer, we know the solution to a system of equations is that intersection point. So you have an x and you have a y. So what do we still have to solve for?
Y.
We still have to solve for the y. So I'm going to take that value and I'm going to substitute it back into one of my original equations. Doesn't matter which one I choose. No. Okay, so I'm going to choose that first one just because it looks easier to me. So I have an equation, I have a variable, I'm going to substitute it in. So I have y equals 6 times 2 minus 11. I have y equals 12 minus 11. And I have y equals 1. So the solution where these 2 points intersect is 2, 1. Yes, I know that is a lot of work, but you should know how to do all of those things. All right, last 4 questions. Number 12, you solve it the exact same way as you do the last one, okay? So you can do that one on your own. So I'm going to go on to elimination so we don't run out of time. All right, 13, solve the linear system using elimination. Okay, so elimination is a different set of rules than substitution. When we're doing substitution, we look to see if one of my equations is solved for a variable. When we're doing elimination, we look to see if we have matching coefficients. So I'm looking at my system. Are there matching coefficients in this system?
Yes.
Yes, I have a 3 and I have a 3. So that's the green light. We can start solving by elimination. Now, after we've checked to see if we have matching coefficients, we look at their signs. Okay, I have a positive 3 and a negative 3. So are those the same sign or opposite? They're opposite. So the rule is if signs are opposite, you add the 2 equations together. Opposite, add, same, subtract. Remember that, write it on a note card. Don't forget that rule, okay? And the reason we have those rules is because our goal is to eliminate a variable. And because we're adding them, that's gonna allow us to eliminate this. So if we have a positive 3 plus a negative 3, what happens? They cancel each other out. So we have just eliminated that variable. Okay, so now we're ready to solve for the rest of the problem. We have a positive 2 plus a positive 4. So that gives us 6y. We have a positive 7 plus a positive 5, that's 12. All right, now I just have to solve for y. How do I get rid of this 6?
Divide by 6.
Divide by 6. Those cancel each other out. And y equals 2. All right, am I done?
No, because you still have to figure out what X is.
Still got to figure out what x is because we know a solution to a system is that intersection point. So I have a variable. What do I have to do with it?
Plug in.
I have to plug it back into one of my equations. Does it matter which one I choose?
No.
Nope, I'm going to choose the top one just because it looks easier to me. So I have 3x plus 2y equals 7. I have an equation. I have a variable. I'm going to substitute it in. Make sure you substitute it into the right variable. So I have 3x plus 2 times 2 equals 7. 3x plus 4 equals 7. Subtract both sides by 4. 3x equals 3. Divide by 3. X equals 1. All right. And you could always double check your answers on Desmos to see if that is in fact the intersection point. But for the test, you will have to show your work. So just know that. I'm trying to check the chat. Hold on. It's not letting me. All right, Kaylin, I am recording this, so if you aren't seeing it, then you can just go back and watch it on YouTube or something later. All right, looks like it did not print the last couple problems, so I'll have to pull those up here in a second. So this one is exactly like the one above it. Okay, so I'm gonna just go ahead and skip that one. This one is solve the system by using multiplication elimination. Okay, so we said that our goal when we're solving for elimination is to check and see if there are any matching coefficients. Does this system have any matching coefficients? No, it doesn't. So when that is the case, we have to create an equivalent equation so that it has matching coefficients. So there's multiple ways you could approach this. But just for us to all be on the same page, I'm going to show you one of them. So there's nothing I can multiply this 4 or 15 by to equal the coefficients below it. Okay, but I have a 1 here and a 5 here. Is there anything I could multiply this 1 by to equal 4?
Yes.
What can I multiply it by?
4.
I could multiply this entire equation by 4. Okay, then I would have matching x coefficients. Is there anything I can multiply this 5 by to equal 15?
Yes.
Yes, what can I multiply it by?
3.
3. Okay, and then I would have matching y coefficients. It doesn't matter which one you choose to do. Really, it's just whichever one you probably notice first. Okay, so I'm going to multiply both of them by 3. Okay, so that's going to create a new system of equations. Did anything change with this top one?
No.
No, so I'm just going to rewrite that one. All right, now let's distribute this 3. What's 3 times negative 1? Negative 3x. 3 times positive 5.
15.
Positive 15y. Negative 13 times 3. Negative 39. All right, now we check. Do I have matching coefficients?
Yes.
Yes. Okay, so now we look at their signs. I have a negative and a positive 15. So if they are opposite, what do we do with our equations?
Add them.
We add them together. All right, I have a negative 4x plus a negative 3x. I get negative 7x. I have negative 15y plus positive 15y. What happens? They cancel. They're eliminated. I have negative 17 plus a negative 39. I get negative 56. So now I just have a regular old equation solving for x. How do I get that x by itself? Divide by negative 7. Those cancel. And x equals 8. Yes, I know I'm going fast, but you can slow this video down. You can stop it and take notes. All right, we're not finished. We have to find y. So I'm going to take my solution. I'm going to substitute back into one of my original equations. Does it matter which one I choose? No, just for this purpose, I'm going to choose the second one because I normally don't. So I have negative 3x plus 15y equals negative 39. I have an equation. I have a variable. What am I to do?
Plug it in.
Plug it in, substitute it. Make sure you plug it into the right variable. So I have negative 3 times 8 plus 15y equals negative 39. What's negative 3 times 8? Negative 24. I'm solving for y, so I start with my term that is furthest away. How do I get rid of a negative 24?
24.
I add 24. I have 15y equals negative 39 plus 24. What do I get? Negative 15. How do I get that y all by itself?
Divide by 15.
Divide by 15. If I do it to one side, gotta do it to the other side. So y equals negative 1. So that is the solution right there. All right, real quick, I'm going to go over that last one that didn't print off for me. Oh, snap. All right, so this is the one that I ended up keeping for all of my classes. Okay, so it gave you a system of inequalities. So you will probably have one similar to this question, but it'll probably just be a different, different inequalities. Okay, so it says for the top line, number 1, meaning this inequality right here, you would graph a solid line and shade it below. Okay, so it's already done for us. So because it's less than or equal to, that's going to make it a solid line. And because it's less than, that means we shade below it. All right, same on this one. It says for this bottom line, number 2, you would graph a dashed line, and it's dashed because it's not equal to right here. And it would also be below the line because it's less than. And so then you would have to match it to its correct graph, which I know that these were really weird, and it also had the same one twice. But that one would be, I think they're all mixed up. Oh my gosh. Sorry guys, I don't know what's happening. So you just have to check their y-intercepts and follow their slope. My computer's being ridiculous. All right, and once again, just a quick reminder that when you are studying, oh wait, I need to share my screen again. You need to make sure that you study these notes. If you have lost these notes for some reason, then you need to go back and watch the lesson where I went over these notes. All right?
Are we allowed to make a postcard?
And yes, you can make a flashcard like the, not the giant flashcards like I have. These are giant. If you can make the ones that are about like half this size, you can use that on your test. Okay, for any rules or anything that you might forget.